Dear students, today in this session I am going to start a new chapter called matrices. From algebra. So first we will see what is meant by a matrix. Okay. I will see in the board a rectangular arrangement of numbers. Rectangular arrangement of numbers in the form of horizontal and vertical lines. In the form of horizontal and vertical lines and enclosed by brackets or parentheses is called matrix. So how the matrix will be in the form of rectangular arrangement. So rectangular arrangement. So rectangular arrangement of numbers in the form of horizontal lines, horizontal and vertical lines enclosed within the square brackets or parenthesis is called a matrix. Okay. So these horizontal lines are called rows. Horizontal lines are called rows. The vertical lines are called columns. The horizontal lines are called rows and the vertical lines are called columns. And whatever the numbers are there, the numbers constituting a matrix, the numbers which constitutes a matrix are called as its elements. Its elements or entries. Okay. So what is meant by elements? The number which constitutes a matrix, which encloses a matrix, are called the elements of the matrix. Are called as elements of the matrix. So in plural form, we can call the matrix as matrices. In plural form, we can call the matrix as matrices. Okay. Now, order of the matrix. Suppose a matrix is having m rows and n columns, then this order is called m into n, that is m by n, or matrix of order m by n. For example, this is the example. How many rows are there? 2 rows are there. 2 into how many columns are there? 3 columns are there. 2 by 3. The order of the matrix is 2 by 3. If you multiply, that symbolizes is equal to 6. That symbolizes 6 elements are there in the matrix. 6 elements are there in the matrix. So 2 represents number of rows by 3 represents number of columns. 2 into 3. That is 2 into 3 is equal to 6. Okay. That is called order of the matrix. Diagonal of a matrix. In a given matrix, the first, second, third elements are called the diagonal of a matrix. That also I will give one example. So, and all the matrices are represented by capital letters A, B, C, D, like that. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So some elements I wrote here. So they are saying first row, first column. First row, first column. Next, second row, second column. Third row, third column. So these elements are called diagonals of the matrix. They are called as diagonals of the matrix. No need to write all these things in your notebook. Just you have to have the idea or basic concepts regarding the matrices. Okay. So now we will discuss the different types of matrices. So one by one we will discuss. Number one is called row matrix. As the name itself indicates, it contains only one row. So what is row matrix? It is having only one row. Example you can give 1, 2, 3. So only it contains only one row. Such type of matrix are called row matrix. So what is the order of this matrix? Only one row, 3 columns, 1 into 3. Correct? 1 into 1 row, 3 columns. So therefore the order of the matrix is what? 1 into 3. So second type is column matrix. Second type is column matrix. Column matrix. As the name itself indicates, it contains only one column. It contains only one column. What is column matrix? It contains only one column. So what is the order of this matrix? 3 rows, 1 column. 3 rows and only one column. That is called as column matrix. Third, you can see rectangular matrix. Third is called rectangular matrix. Rectangular matrix. So what is meant by rectangular matrix? Number of rows is not equal to number of columns. Number of rows is not equal to number of columns. Number of rows and number of columns are not equal. Such type of matrix are called rectangular matrix. For example, C is equal to 2, 3, 5, 6, 7, 8. So such type of matrix, because number of rows how many are there here? 2. How many number of columns are there? 3. So they are not equal. So number of rows are not equal to number of columns. Such type of matrix is called rectangular matrix. Okay. Now we will go to fourth one, square matrix. Fourth one, we will discuss about square matrix. What is meant by square matrix? Here, both number of rows and number of columns are equal to each other. A, B, C, D, E, F, G, H, I. So number of rows and number of columns both should be equal to each other. Then only we can call it as square matrix. See, for example, how many rows? 3. How many columns? How many rows? 3 rows. How many columns? 3 columns. 3 into 3, 9. So perfect square. So therefore, here in square matrix, number of rows should be equal to number of columns. So don't forget it. So diagonal matrix, we will see. Fifth one, diagonal matrix. Diagonal matrix. So what is meant by diagonal matrix? A square, it is also a square matrix. That means it will be having number of rows and number of columns are equal. But every non-diagonal element is 0. Every non-diagonal elements are 0. For example, so 1, 0, 0, 0, 2, 0, 0, 0, 3. So it is also square matrix, but the except diagonal elements, other elements are 0. Except diagonal elements, other elements are 0. See up to here, 1, 2, 3 is the diagonal elements and the remaining elements will be 0. Such type of matrix is called diagonal matrix. Now come to sixth type, unit or identity matrix. Unit or identity matrix. Unit or identity matrix. What is unit matrix or identity matrix? Here it is also square matrix, but the diagonal elements will be compulsorily equal to 1. Other elements will be 0. It is also square matrix, whereas the diagonal element should be equal to 1 and the remaining elements should be equal to 0. For example, 1 0 0 1. It is called unit matrix or identity matrix. Why it is called unit matrix or identity matrix? It is nothing but a square matrix, whereas the diagonal elements should be equal to 1 and other elements will be equal to 0. So that is so observe here, difference between diagonal matrix and unit matrix is, in a diagonal matrix, diagonal elements will be different, but other elements will be 0. But here, diagonal elements will be equal to 1 and other elements will be 0. So, now we'll move on to the next type. Now we move on to the next type. 0 or null matrix. 0 or null matrix. 0 or null matrix. As the name itself indicates, it is the elements in which all the elements in the matrix will be 0. All the elements in the matrix will be 0, 0, 0, 0, 0. Such type of elements are called, such type of matrix are called 0 or null matrices. Null matrices. Okay. Now we'll come to next type, equal matrices. Equal matrices. When you say that the two matrices are equal, we can say that the two matrices are equal when they have same order. For example, A is equal to 1, 2, 3, 4. B is equal to 3, 4, 6, 7. They should have same order. And sorry, I wrote a different one. I will write here. They should have same order, and the elements are also should be equal. All the elements of both the matrix should be equal. The order should be same. Elements should be same. Then only we can say that they are called equal matrices. Equal matrices. Remember these points. Next, I will discuss about one more thing. Transpose of a matrix. Transpose of a matrix. Transpose of a matrix. Suppose one matrix is there. 1, 2, 3, 4. You have to write the transpose. Transpose is always represented by AT or small t, you can say small t. AT. That means what you should write here, whatever there the elements in the row, we should write it in columns. 1, 2, 3, 4. This is called transpose of a matrix. So what is meant by transpose of a matrix? The elements which are there in the matrix should be written in the column. So whatever the elements are there in the row, that should be written in the column wise. See, observe here, A matrix contains 1, 2, 3, 4 elements. So after writing, I am writing in the transpose of the matrix. What I am doing, I am writing all the elements of the row in the column wise. So 1, 2, 1, 2, 3, 4, 3, 4. So such type of matrices are called transpose of a matrices. Transpose of a matrices. So you remember these different types of matrices what we have discussed. Now we will move on to the exercise based on the basic concepts. Exercise number 9A. So exercise 9A, write first main order of each of the following matrices. I will show you only one sum because I have already explained in the basic concepts. 3, minus 7, minus 5, minus 7, minus 6, 9, 4. So what is the order of this matrix? How many rows are there? 2 rows are there. How many rows? 2 rows. How many columns are there? First column, second column, third column. So 2 into 3. So you have to count the rows, you have to count the columns, number of columns. So 2 by 3. So what of the matrix is 2 by 3. Remaining questions, second to sixth, you can take it as homework. Second to sixth homework. Now second one. Classify the following matrix. Classify the following matrices. Classify the following matrices. First one is 9, 3, minus 4. So only one column is there. Only one column is there. That means what type of matrix it is? Column matrix. So column matrix. You have to write like this. Column matrix. I think you will do second one. That is 7 minus 8, 9, 4. It is what type of matrix? Square matrix. Third, 8 minus 7, 2. Row matrix because only one row is there. 1, 0, 0, 1. Diagonal elements contains only 1 and other elements are 0. Therefore, it is unit matrix. 6, 0, 0, 0, 3, 0, 0, 0, minus 2. Fifth one. It contains diagonal elements and other elements are 0, therefore it is diagonal matrix. And 0, 0, 0, 0, 0, 0, that is all the elements of the matrix are 0, therefore it is called null matrix. You write down the remaining questions, that is second to sixth homework. Third, construct 2 into 3 matrix. Construct a 2 into 3 matrix. Construct a 2 into 3 matrix whose elements A, I, J. What is that I? I represents rows, J represents column. In which row and which column it is there, that element, particular element of the matrix is situating at which row and which column. That is the I represents row, J represents column. Remember that. Are given by one equation they are given. A, I, J is equal to 3I minus J. 3I minus J. Using this equation, we have to find the elements of the matrix. Now we will find out, that means 2 rows will be there, 3 columns will be there. 2 rows, 3 columns. Now we will find out first row. First column. A 1, I means 1, J means 1. That is equal to 3 into 1 minus 1. That is 3 minus 1. That is equal to 2. Now, first row, second column. A 1, 2. 3 into 1 minus 2. 3 minus 2 is equal to 1. Now, first row, third column. 3 into 1 minus 3. 3 minus 3 is equal to 0. 2, 1, 0. 2, 1, 0. Now we will come to second. A to first column. A to 1. Second row. 2 means second row. 1 means first column. That is 3 into I means what here? 2 minus 1. 6 minus 1 is equal to 5. Next, A 2, 2. Second row, second column. 3 into 2 minus 2 is equal to 6 minus 2. That is 4. Next, A 2, 3. Second row, third column. So 3 into I means 2 minus 3. 6 minus 3 is equal to 3. So now we have to write the matrix. So matrix is 2, 1, 0, 5, 4, 3. So 2 into 3 matrix. So 2, 1, 0 will be in the first row, 5, 4, 3 will be in the second row. So using this equation, we find it out. So I told you what is the number symbolizes. The first number symbolizes first row and second number symbolizes column. First row, first column. First row, second column. First row, third column. Second row, first column. Second row, second column. Second row, third column. So what are the elements are situated? So like this, we have to find out. So same type of the sum is given in the question number 4. So I will give 4th as homework. You do it. Okay? So note down these sums. So fifth question it says, if a matrix has 4 elements, what are the possible orders it can have? Find out the factors of 4. Okay? 1 into 4 possible orders are 1 into 4 you can take one row, first one row, 4 columns, one row, 4 columns. Or we can take 4 into 1 also, 4 rows, 1 column, 4 rows, 1 column. Or we can take 2 into 2 also, 2 rows, 2 columns. So these are the some possible orders we can take. 1 row, 4 columns we can take because 4 into 1, 4. Or 4 rows, 1 column we can take. 4 1 just 4 elements it can take. Or 2 rows, 2 columns. 2 into 2, 4. So any orders we can take. Okay? Any of these 3 orders. So sixth one, same question they asked. I will give it as homework. In a matrix of 6 elements, what are the possible orders it can have? You can do it in your own. Now seventh one I am coming. Seventh one. Find the values of A, B, C, D. Find the values of A, B, C, D when so matrix they are given A plus 3, 4 minus 2, B minus 6 is equal to minus 1, C minus 3, D plus 1, 2. So A, B, C, D you have to find out. So first element of the first matrix, first row, first element of the first matrix, because they are saying they are equal matrix. So first row, first element of the first matrix should be equal to the first row and first element, first column elements of the second matrix. Therefore, A plus 3 is equal to minus 1 or A is equal to minus 3 minus 1 is equal to 4. So A value we got. Now I will take B. So B should be equal to this, correct? So second row, second column of the first matrix should be equal to second row, second column of the second matrix. Therefore, B minus 6 is equal to 2 or B is equal to 6 plus 2 is equal to 8. Similarly, we can find out 4 is equal to C minus 3 or C is equal to 4 plus 3 is equal to 7. C value is 7. D where is the D? So this, okay, minus 2 is equal to D plus 1 or D is equal to minus 2 minus 1 is equal to minus 3. So A value 4, B value minus 4, B value is 8, C value is 7, D value is minus 3. So in this way we can find out, because they are called equal matrix, later we can find out. Equal matrix means order should be same, here orders are also same, and the elements should also be same. Elements also should be same. Okay? Do it. Similarly, you can find out question number 9. Sorry, question number 8 as homework. I am giving question number 8 as homework. So note all these sums. So, ninth question, find the values of x, y, a and b. When? So these are the values. They are equal matrix because orders are also same and compulsory what should be same? The elements also should be same. That means x plus y should be equal to 5. One more x plus comes 2x minus 3y should be equal to minus 5. Equation 1, equation 2. Two more equations I can take. A plus b is equal to minus 1. A minus b is equal to 3. Equation 3, equation 4. Like that we can make separate equations. Solve for x and y. Solve for x and y. So into 2 into 1. Coordinates of coefficients of x I am multiplying. Equation 1 with coefficients of x of equation 2 and equation 2 with the coefficients of x of equation 1. So 2x plus 2y is equal to 10. 2x minus 3y is equal to minus 5. Okay? So plus minus cancels, here plus 5y is equal to 15. Y is equal to 15 by 5, that is equal to 3. Y value is 3. Substitute y is equal to 3 in equation number 1. X plus y is equal to 5. X plus 3 is equal to 5. This implies x is equal to 5 minus 3 is equal to 2. So this is the first part. Now come to the second part. Direct add. 2a is equal to 2. A is equal to 2 by 2. 1. Substitute a is equal to 1 in equation number 3. A plus b is equal to minus 1. 1 plus b is equal to minus 1. B is equal to minus 1, minus 2. So a value we got, b value we got, x value we got, and y value also. In this way we can do this sum. So note this. So last main of this exercise is find the transpose of each of the following matrices given below. A is 2, 3, 5 minus 7. So transpose means we have to write 80. First row in first column, second row in second column. First row what is there? 2, 3 in first column I wrote. Second column element, second row element 5 minus 4. We have to write in second column. So first row in first column, second row in second column. We have to write. So this is how we can write the transpose. Second, 5, 7 minus 3. 5, 7 minus 3. Row matrix they are given. B, T is equal to. So 5, first row in first column. 5, 7 minus 3. It becomes what? It becomes a column matrix. So third one, you do it as a homework. So by this I completed the first exercise. So practice well, write all the problems in the notes and show me when school the homework. Thank you.